Okay. So we get onto the filling and placement procedures, and I'll run through the different container types. The 0.35 and the 0.75 cubic meters use the same filling procedure. Basically what you need is 2 filling frames. We recommend 2 filling frames only because from my experience that when you get out there, an excavator is going to run over one of your filling frames and break it. So you'd rather have a backup as a second one there as a helping hand. 2 sewing machines, and any of you, the Gold Coast guys were talking to me about the sewing machines. You need 2 sewing machines, not because you're going to sew with both of them at once, but from my experience, if you go onto site, one of them will break down somewhere along during the work that you're doing. So the second one there is the backup. The generator to run the sewing machines, the J-bin for the placement. We used to use modified rock grabs to pick up and place our containers. What we found was happening was it was actually putting stress on the geotextiles and damaging the geotextiles in using the modified rock grabs. So we've now developed J-bins that pick them up. They're like an excavator bucket, really. They're just like a wide trimming bucket that we've developed to pick up the containers and move them around and place them. It puts limited stress on the geotextiles, and actually you get a very nice finish with those. A 6 to 8 ton excavator to fill the containers, and a 13 to 20 ton excavator to pick them up and place them in the structure. So there's a step-by-step process that you have to go through in terms of filling and placing the containers, and we have detailed guidelines in terms of how to do that work. So if you're going down the route, we'll have the instructions as to how to go through the process, and we'll also provide training, on-site training. So somebody from Geofabrics will go through with your staff and train you how to do this. So basically it's a simple enough procedure. Once you've done it, it's certainly not rocket science. So you've done it a couple of times, you'll feel quite comfortable with it. So it's basically placing the frame on a level surface, placing the container up through the middle of the frame and folding it over the top. And just with the placement, one of the seams has to go towards the center pole, but these are details that we'll go through on site in a lot more detail. The container, we need to make sure that the container is hanging slightly off the base of the frame, only because if we rest it on the ground, the first drop of sand that goes into you sometimes get folds in the container, and then you don't get the container filling as well as it could be. One of the tricks with the vandal deterrent material is when you're putting it over those frames, it can be quite stiff, tough material to work with, that you do the fold first and then just slide it down over the top of the container. You clamp the fastening ring in place. Okay. So the next process is then to drop the sand into the frames. Once it's filled to within about 300 mils at the top of the filling frame, you release the frame, move it away, and then sew up the top and move the frame onto the next zone for filling. Okay. The sewing procedure to close the container, you have to push the sand into the corners of the containers, and again, just to make sure that you have enough space to sew the top of the containers. There should be about 75 and 100 mils of space that you need to sew the container closed. The key with that is that if you have anything less than that, what we find is the sewing machines get jammed up. The guys run it into the sand, and it jams the sewing machine up, and you land up breaking sewing machines. So you need a bit 75 to 100 mils of free area to close the containers with. It has 3 layers of stitching. So basically the first row of stitching is a straight stitch, and then we do a sine wave over the top of it. The sewing machines that we use are chain stitch sewing machines, so that you can actually unravel the stitching. So the idea is that the sine wave that crosses over that first straight stitch locks off that stitching, and then the corners are locked off with 2 rows of stitching. And I've got a video there. So it's a 1.5 minute process to sew one of these containers closed. And that's the handheld sewing machine, and it's not very heavy, but after you've spent a day doing it, you get forearm pump. You feel like Arnold Schwarzenegger by the end of the day. And so we often recommend that you have a couple of guys trained on site to do it, because what I find is by the end of the day, some of the operators are starting to get tired of doing it, and that's when jams occur with the sewing machines. So that's the sewing across the straight line, the sine wave, just checking that we haven't dropped any stitches along the way, that we haven't run into a shell or got the machine jammed, and then locking off of those corners, the corners of the containers. The other thing to bear in mind, you need to use the proper yarn for those sewing machines. The yarn that we supply with the sewing machines are expensive, but there's a reason for it. It's good quality yarn. It's polyester yarn. You can get poly cotton yarn that is probably half the price, but it just deteriorates with water and sunlight really quickly. So there's a reason why that yarn is expensive at the end of the day. In terms of placement of the containers, you push the container over to the side. What you want is those seams sitting parallel with the base. Okay. You then come along and you lift up the container with the J-bin. It's getting underneath the container, lifting it up, and then moving it on into position. What you've got to do is just shake out the sand that gets trapped underneath the J-bin. And we've recently changed the J-bins that they have holes at the base of them so that they can get the sand out from underneath the containers when you place it. So when you shake it around, you can get the sand out from underneath it. It's a simple matter of just like sliding the container out of the J-bin, and it'll take a few times. The excavator operators will get really handy with this. They're not going to get it straight away, but after a few tries with it, you can really get a nice, neat structure. And what you're seeing here is a project where the containers are stacked nicely. They've got nice height. They're butting up against each other. And that's what you want. You want the containers packed in nicely against each other. You want the depth, the 400 mil height out of those containers to make sure that the container structure stays stable. Again, as I said earlier, what we like to see is sand covering over the containers. A, it gets sand into the geotextile material to help with the vandalism, and B, it can look quite aesthetically pleasing. When the structure's hidden, nobody sees it. It's only rarely gets exposed during big storm events. This is a project down in Victoria where they actually planted grass in the gaps between the containers, and that seems to work reasonably well. It dies back when it gets wave action on it, but it seems to regrow once the waves have moved away. Okay, the 2.5 cubic meter containers. Here you need specialized filling apparatus because of the method, because the containers are so big. You need a generator to run a 50 mil high pressure water hose because these containers are filled with water pumped into them. It helps with the compaction of the sand within the containers and makes sure that we have a really dense structure. You need the 6 to 13 ton excavator for the filling of the containers, and then the 20 to 35 ton excavator to pick up the structure, or the bags. Now, 35 ton excavator seems a big excavator to pick up a nominal 5 ton container. But it's because of the way the equipment is manufactured that if you want to come from one side, you actually have to put your boom at full extension, and then to lift up 5 tons at full extension with the boom on an excavator, you need a 35 ton excavator to do that. If you don't have a 35 ton excavator, you can use a 20 tonner, but he has to move either side of the filling apparatus to pick up the containers. Okay. So the assembly, we supply the equipment that comes along with it, and over the years we've developed this equipment more and more. With every job that we go out to, we learn a little bit more, and we've made slight changes to the apparatus to improve the apparatus. But at the moment we have these apparatuses all over the country, and it used to be we used to have one piece of equipment that did the whole country. But with the concept catching on, we now have one in each branch, and we have the ability to bring them from elsewhere in the country if we have a number of projects going on at any one time. But basically you have a base, you place a mast on it, and then these hoppers that feed the sand into the containers, and then the J-bins that you saw, the smaller versions for the 0.75 cubic meter containers. In the 2.5 cubic meter containers, they've actually filled inside those J-bins. The key is to unfold the container, and it's a two-man job to get those containers picked up. They weigh about 30-odd kgs, so they're just over the 25 kgs mark. 2 people, you clamp, we have a little lifting device, you clamp it onto the top of the container, pull it up until the container sits just below the trunks of the hoppers. Then start filling the excavator. There's also water jets that run. You have to connect a water pump up to the top of the hopper system so that it jets water into the hopper. When we initially started filling these containers, what we found was that if we dry filled them, that we get sand choking up in the neck of the hoppers. So we built in the water jets in there to help wash that sand out of the hoppers and into the containers. They then filled with an excavator. This guy, I think that's me, yeah. That's me standing underneath there with no hard hat and an excavator over the top of me. We've now changed the equipment that we have a shield that sits over a heavy-duty shield that sits over the top of you, and we also recommend you wear a hard hat when you're out there doing that. So changes like that, we've changed the way the water jets go into the trunks and so on. So all these sort of improvements to make the construction procedure so much easier. In terms of the closure of these containers, we haven't used the sewing machines in here because we're using wet fill. And that's just something to remind you with the sewing machines. Please don't operate them in the wet. Again, I had a contractor in North Queensland that phoned me up and was abusing me and using words that I'm used to, but I hadn't heard so many in one sentence. And it turned out when I went out to site, he had a handheld sewing machine. He was standing sort of this deep in the sea, sewing up his sandbags with the sewing machine, with the cord around his neck, with the plug sitting up in this portion of it so it was out of the water, the cable running under the water out to his generator on the foreshore. So I'd recommend you don't go down that route. I mean, but you see this all the time, so just be aware of it. You know, guys, we send this equipment out there, but you have to use OH&S when you get it out there. So basically, with the 2.5 cubic meter containers, we've gone away from the sewing machines because of all the water around there, and it's basically a trunk system. You push those trunks in that attach to the hopper back into the containers, and then it's laced closed at the top, and the ropes are sealed off with silicone because what was happening was that under wave action, the ropes were untangling. So that silicone there is to make sure that the knots don't untie under wave action. The placement of the containers, I'll show the video. We've got the process written there, but I'll walk you through in terms of the video that goes through the process of the whole filling and placement operation here. So this is Maroochydore groins. In this stage, they've actually placed the container in the J-bin. You see the excavator's reaching over the top of the structure. He's got 2 V points that he's locating the J-bin in. Now that's got that bar there is the locating point. Again, it takes a little bit of experience from the contractor, but within a day they've normally got that down pat in terms of how to place those things. The hopper's swung around to above the J-bin. They clamp the lifting device onto the top of the container. It's lifted into position, and then the container is clamped onto that hopper system up there. The recent changes in the design is to make those steps a lot safer. We now have wide steps so that people can't slip off and injure themselves. The clamps, the top step that they stand on has got an anti-slip area and so on. So those, we actually, after a while of running through this, we actually got an OH&S expert to come in and give us advice on what we should be doing with these things, because basically it was between 2 of us that did this design of the thing, and we probably weren't OH&S orientated when we originally did the design. It's simply clamped off at the top. They then fill in the containers. And the guy up there is just turning the water jets on and making sure the water goes from one side to the other side as you're filling the containers. If you have enough water on site, so if you run off a fire hydrant, where you've got a lot of water pressure, you actually don't need anybody up there. It's only when you run with the flex drive 50 mil pumps that don't give a lot of water pressure that we actually advise that you fill one side and then the other side and you turn the water on for that. What you're seeing is the water coming out of the containers. So it's basically compacting the containers in there. The tying off procedure, and this is probably the longest part of the filling process, is tying off and closing off the containers. Those are the trunks. They actually tied off with a cable tie, pushed back inside and tied off. And the key to realize when you're seeing these structures being built is the fill height. When you're filling the containers, it should be to within 200 mils of the top of the container, or when they're in place, they should be at least 600 mils higher, these 2.5 cubic meter containers. They should stand, then you know you fill the structure properly. That's the locking, the glue. They come back on and attach to the quick hitch. The quick hitches that we have here are bolt-on quick hitches, so depending on your equipment that you have, we'll make the quick hitch to suit your equipment. We have a range of quick hitches now over the years that we've been doing it, so we've got a number of different quick hitches. So just all that we ask you is you let us know what your equipment is before it gets out onto site, because I've often been out, the guys say, oh, I've got a ZX200, but they've put a different quick hitch fitting on the thing, and then we get it to site and it doesn't fit, and so on. So just work with us on that side of the thing and making sure that you have the right equipment, otherwise you're going to be sitting there. It takes about 3 weeks to get a quick hitch made up, so you don't want to be held up for 3 weeks if you don't need to be. You see the placement procedure, really simple. It's easy to get accurate placement to these containers, but you'd be looking at around 5 containers an hour. Once the guys get experience, they'll be doing 5 of those 2.5 cubic meter containers an hour. Again, the finishing, if we can cover it with soil and material, that obviously adds. If you bury these containers, their life is hundreds of years. It's a plastic-based material that we're working with. If it's buried, the life is over 100 years. It's only when it becomes exposed that you need to deal with these other UV and vandalism and so on. Okay. The mega containers, the big tubes, what you need is a 8 to 12 inch dredge. What we'd recommend if you start going above the 10-inch dredge levels, that you have a Y piece on there that can divert water pressure out of it, particularly when you're dredging for long distances. We've had a project recently where the contractor was dredging for, I think it was about 1 kilometre he was dredging. He was using very large coral shards in there, and what was happening was that his dredge pipe was blocking up. So he'd ramp up the pressure of his pump to clear his pipes out, and it'd build up, and then suddenly there'd be this massive water that would come shooting out of the end of the thing. It'd be like a water hammer going into your bag, and we were popping tubes at the end of it. So if you're going to do that sort of thing, we can understand it. I have a Y piece separating so that you can divert some of that pressure off if you're having to blast out your dredge hoses. Simple one ratchet tie down to anchor onto the trunks. Anchors, whether it be concrete blocks or fence posts to hold the mega container in place, and then rope to tie it off. And I'll go through the procedure in terms of placing the structure. That's what you're seeing in terms of the placement of the anchor points. Those are the anchor points running down either side of the mega containers. You tie off. This is a nice example. There's no waves, there's no tidal action in there. It's a really easy installation. When you start talking about installations in the surf zone or in places where there's tidal currents or water movement, what we'd say is tie off this first anchor point, roll it out 5 meters, tie off your second one, and slow on incrementally, because these things become big parachutes when you start talking about wave currents. And once the current grabs hold of one of these things, there's very little that'll hold it on. And it certainly won't be held on by a single anchor point. It'll just rip the anchor points out. So basically the 5 meter increments that you should roll it out to, and you tie it off as you go along. unfold the geotext, the container, as you roll it out, and then just adjust the tension on the ropes at your anchor points to make sure it's all in the right alignment. The standard containers come with 3 trunks, and those are both as filling ports and exhaust ports to allow the water out. When you're dredging, you're only dredging 10 to 15% solids. Those solids fall out of suspension as it gets into the container, and that's what fills the container. But you have a lot of discharge water that comes out of the exhaust ports. So you need to have the pipe going into one of the inlet ports, and the other 2 ports are discharge ports. What we wouldn't recommend is that you tie off those outlet ports unless you have a very low volume dredge. But then you also have to be careful that you don't overstress the geotextiles at the same time. Just make sure that the dredge line pipes points down the length of the tube. If you start pointing it in to the side, the tube will want to roll in the direction that you're pointing your dredge in. And if you point it downwards, what we found is that you have scour occurring at that point because it's pushing high velocity water at that point. So you want it the water running along the top of the container. Okay. You clamp the trunk onto the top with the ratchet tie down. The only thing that you have to be aware of is that there are maximum pump heights that these tubes can go to, and we'll give you advice on what those maximum pump heights, because if you exceed that, you're actually overstressing the geotextile. It's like a balloon. If you blow it up too much, it's going to pop at some stage. So we'd give you the maximum height depending on whether the structure is submerged or emergent and so on. So there are guidelines in terms of those figures. Okay. Once you start pumping in the mixture of slurry and sand, that's the sort of structure that you're seeing. The tube itself inflates, and you have this discharge water coming out the other 2 ports. You may have to, depending on your site, deal with that discharge water, and it will be dirty. It's very rare that that's going to come out nice and clean. And in terms of measuring how far your sand level is, up the side of it, it's simply a practical method of just putting your heel into the side of it. When there's give, that the sand hasn't got there, you can feel the edge of the sand inside the containers. Filling should be between 30 minutes and 2 hours, depending on your dredge and the quality of your fill material that you're using. It really is dependent on those factors. We've taken a whole day to fill containers because the guys have been using marine mud to fill the containers. So it just depends on the fill material that you're using. The discharge, I said earlier, the discharge port shouldn't be closed. And once it's completed, you need to cut the tags off as closely as possible to the side of the containers. What we found with narrow neck reef was that we didn't cut off the tags, and we had conjivori growing on the tags, and they've become these big lumps, and they were just spinning in the wave and wearing out the geotextile. So we've now cut those things off so that we don't have any growth, so that there's no potential for wear on the containers. Now there's a video here, and it's the best video I have of filling these containers, but there are a few things that I need to show you that's probably not the right way to go. It's important that you place the posts far enough out. What these guys have done is they've placed posts right up against the side of the containers, and you'll see that that's folded over. So once they start filling, it'll just push those posts out because they've actually made the posts too narrow in terms of the way they've placed it. The contractor sent us this video. It's come out really well, this structure, but I think he had a lot of good luck when he did it, to be honest. So that's tying off the inlet port with the ratchet. And basically these trunks get held inside or get pushed back into it once it's filled up. So you see the container slowly filling up with water, and it's starting to push those anchor points out. So you're seeing it all pushing out on the side. Now, once we get into the container, he's going to go around and see how high the sand level is in the side of the containers, and that's the process that he's going on just to see whether his container's full or not. The concerning thing for me with this structure was that somewhere along the line they closed off these outlet ports, and you'll see the size of the container. This thing is well and truly overinflated. When I saw it, I couldn't believe that it had actually survived the installation process that was going on there. They've closed off that installation outlet port, and they're running off a single outlet port there. So that thing is almost like a round tube, and that once it gets to the shape of a round tube, you're starting to overstress that geotextile. So that's the finished product. I don't think you'll ever see another tube built to that height. And again, it was fantastic that it survived it. But yeah, and again, you can see that slight rolling of the containers. It's the direction that you put your inlet port in terms of controlling that. But they were running a little 8-inch dredge on that job. In terms of closing it off, it's a matter of pushing the trunks back in, the outlet ports, and then there's a laced closure. We supply a rope with it. You lace the top of the container closed. There should be another slide photograph, and then we place a patch over the top of it. Those are screwed down with screws that look like your wall mates that you get from Bunnings and those places. It's just got a very coarse thread that locks in with the geotextile. Very difficult for you to get those screws out unless you have a screwdriver with you. Basically, it's glued down, and we run a bead of glue around the edge to make sure it can't be lifted by wave action. In terms of repairs, the same procedure as the patch over the top of the closure of the containers. What we can supply patches that have already got pre-burnt holes in the top of them. So whatever size your hole is in your container, we'll make a patch up to suit. We'll burn holes in it. You put the silicone glue on the surface of that, push it down, and screw that patch in place. It holds really well, and once the screws are there primarily while the glue sets, because most of these structures are in the wet, and you need to hold the patch in place while the glue dries. So in some cases you don't need the screws, but we'd always recommend it because, again, some people have tried to pull these things off during the time that we've been around. In terms of the key projects that have been on around the country, Russell Head's groin up just south of Cairns was built in 1993. It's been around 17 years, and this is one of the first structures that we used with our standard containers that has really got to the end of its life. Neil was up on the site a little while ago. It was done with tubes. The geotextile is starting to deteriorate quite badly. So it's kind of reached the end of its lifespan. We are looking at doing the owners are looking at doing some more work up there with new containers. I think you guys have manufactured the containers for the site at this stage. Stockton Beach in New South Wales, it's been in for 14 years. Narrowneck Reef, 11 years. Marucci Groin has been in 9 years. The groins have been in 9 years. Rockingham over in WA, and then Aspendale in Victoria. I've just shown you that these structures are all around the country at the moment. And what we've been doing of late is doing some exhumations off the site. So we're taking those structures and we're sampling geotextiles off that just to check the longevity of these structures to try and get an indication of how long they'll last. So we've sampled products off Stockton Beach and off Maroochydore Groin to estimate the life of the structures, and the results have come out quite positive with those. We've just done a paper, so if anybody's interested in that, I can supply that to you. But these are the types of structures that you're seeing. Stockton Beach, not much change from 2001 to 2009. Maroochydore Beach, this is pretty much all covered up at the moment. You can't see much of that wall, just the top layer. It comes out every now and again after big storms. And then Aspendale Beach, and this is one of my favourite photographs because this is really what the advantage of these systems, that people can go and sit on them and lay their towels out and relax on these structures rather than the rock structures. And in this site, just for your interest, the residents here were very anti the idea of going in with a geotextile structure initially. They said it was sandbags, and they'd seen sandbags before, and they all failed, and they thinking of the Hessian sandbags that had been used for years. The project went ahead, and the key benefit for the residents there was that they suddenly realized that they had far less of a rat problem in the area, because the rats had moved into all their rock walls in front of their structures, and the rats are not getting into these structures. And we did, 3 years later, we did the extension of the structure, and the council, after all the problems, all the letters that had been in the newspaper saying they didn't like these sandbag structures, decided to build a rock structure. The residents then got up in arms and said, no, we don't want a rock structure, we want one of those sandbag structures now. So they then opened it up to tender, and it went out to tender with, they could run with alternatives. The container wall came in at about 6% more expensive than the rock structure for the site. But based on resident pressure, they went with the Alka rock structure on the project. So that's been really good for us at the end of the day. Groins, this is Russell Heads that we spoke about. This is 1995. It's a little spit. There's a bunch of guys that have got holiday shacks on this little spit. This is the Russell River. Much like Maroochydore, the mouth of the Russell River changed, and their beach eroded from out there somewhere to, they were about to lose their houses. What you see here is a structure with all sorts of funny little designs with it, because the residents built this structure themselves. And basically, they took 1.5 meter or 1.2 meter diameter tubes, and they, on working bees, they filled them up. And they, across the beach section here, they laid a tube down, let the sand fill in behind the tube, then placed the next tube on top of it. Let the sand naturally accrete behind it, and place the next tube on top of it. So they built a wall that was about 4 meters high across that front surface. And over time, that whole beach is renourished. I mean, you see the photographs now, there's trees in here and you wouldn't recognize it. However, this wall is in bad, it isn't in a great condition. It needs repairing and it needs maintenance. Maroochydore Beach, which has survived pretty well, they did some maintenance on the structure last year. We originally supplied about 4,500 containers, and they replaced 100 of those containers the end of last year, end of 2009. So 8 years after the first construction, they replaced 100 containers on that structure. And that was primarily around the crest areas and at the heads of the structures where there had been dislodgement of containers and some vandalism. And then Elliott Heads, much the same sort of structure, private landowner. I'm not too sure how he pulled it off, but he managed to convince EPA that his boundary is out there somewhere, about 50 meters off the end of that groin. He'd lost about 150 meters. So he's managed to reclaim a fair bit of land like that. I'm amazed that he managed to convince the authorities that he could do that, but he's pulled it off, and it seems to be working pretty well for him. The offshore structures, Narrow-neck Reef is probably the highest profile structure that we've ever built. Lots of good and bad publicity about that structure. But the key for us is what we learnt out of that structure. We've learned so much out of building that structure in terms of the geotextiles that should be used, the manufacturing techniques and the methods to place it. It's been invaluable for the geosynthetics industry. I think Council's still reasonably happy with it. Depends on who you talk to, I suppose. And I've just got some video footage of the structure, which is quite nice. It just shows, this is the Narrow-neck before. Please don't be fooled into thinking that beach looks like it's been repaired because of the structure. They did a lot of beach nourishment on that beach. So the condition of the beach now, this condition is not because of the reef, it's because of the extensive beach nourishment that went ahead on the site. But really, I think the key with the Narrow-neck Reef is it'll come into its own if we ever get hit by a cyclone again, because it will reduce the energy impact onto that foreshore area. For the guys that say there's no surf on the beach, there is from time to time. It depends on what the tide is and what the swell's like. But it's pretty much like any other beach break, except it's a long way out. This is a fair way out. If you have to swim out to, it's about 400 meters to swim out. It's certainly not a near shore break. And I took this video footage, so that's probably why the quality is not all that great. And then there's some underwater footage, and this is where it comes into its own. I've dived on this thing over the years, and it's just the marine growth around on the structure is just amazing. A few years ago, the National Marine Science Centre they had a PhD student that came up and did an analysis on the sea life attracted to the structure, and they compared it to Kero Reef, to Palm Beach Reef, and then to Cook Island. And what they found was that there was a higher percentage of fish on this reef than on the other reefs, although they were coming here as a food source because of the algae growth on the containers. They weren't using it as a breeding ground because there wasn't enough complexity in the structure itself. But from a food source point of view, that's great. We thought that was a really good thing until environmentalists got onto us and said, well, you're now making it too easy for the fishermen to catch the fish. So that kind of became a black eye for us. So, sometimes you just can't win. But it is a great place to go out. And I mean, for me, it's a nice place to dive because I know what went into building it. But there is a lot of marine life around the area. We can shut it off now. But we've got videos and that sort of thing if you need those sort of things out there. Then Lime Burners Breakwater was built it's just near Geelong, and it's a 5.5 metre high structure, 80 metres long, that we built, that basically 3 layers of geotubes at the bottom, then 2, and then a single one at the crest. And that protects the mouth of a boat harbour, stopping waves getting into the boat harbour.